In this session, we will briefly discuss matter, what makes matter matter and what is not matter. We will also briefly discuss physical states of matter and also certain terminologies that are applied when states of matter change from one to another. Okay, so what is matter? Matter is anything and everything that has mass and occupies space, in other words, has volume as well. If I asked you to give me some examples of matter around you, I'm sure you can come up with many examples because anything around you, everything around you is matter unless it is heat, light, sound, etc. Those are not matter because they neither have mass nor do they have volume. Volume in terms of space that they occupy. Those are waves, those are energies. So universe is made up of matter and it's made up of energy. So matter, food is matter, you is a matter, I am a matter, table, chair, air that you breathe in, water, your pet, your favorite pet, books, pens, pencils, paper. I mean, all of those things are matter because they have a mass and they occupy space. Matter exists in three physical states that we will discuss. Of course, there are others that we won't discuss. We will only discuss solids, liquids, and gases. Now, if I were to ask you to take a minute, pause the recording, and list down some of the differences that you can observe between solid, liquid, and gas, please go ahead and do that for a minute. Solids are characterized by having their own shape and their own volume no matter where you place them. Unless you change the temperature pressure, a solid object would have its own volume and its own shape. Solids, generally speaking, also have the highest density of the three physical states, and solids are the least compressible of the three physical states. Compressibility means the ability of an object to reduce its volume when pressure is applied. Solids, compared to the three, have the least ability to be compressed. Density, they do have the highest density, but there is a notable anomaly. There's a notable exception to this rule, and that happens to be ice. Ice is solid water, yet ice floats on liquid water because ice is one of those exceptions where solid state actually has a lower density than the liquid state. But in general, solids do have the highest density. Liquids have a definite volume of their own, but they take the shape of the container. Their density is between those of solids and gases. Of course, their densities are closer to that of the solids. They're not like right in the middle of the two, but liquids are slightly less dense than solid phases of that substance would be. And similarly, liquid phases have low compressibility, yet they have higher compressibility than solids. I mean, they are more compressible than solids, but only slightly so. Gases, on the other hand, have neither their own volume nor their own shape. They take both the volume and the shape of the container that holds them. They have the lowest density of the three physical states, and they are the most compressible. I'm sure when you are driving on a highway, you've probably driven by a tanker truck that is carrying compressed gas of some kind under, of course, cold temperatures and very high pressures. You may have driven by a truck carrying these cylinders of liquid nitrogen. Liquid oxygen is very commonly available as well. So gases are definitely more common to be compressed. They are more compressible. So the question arises then that what is the basic difference in their in the three physical states, which then leads to these observable differences in their properties. The fundamental difference between the three physical states of matter is the space that exists between individual particles of those substances. Solid state have very closely packed particles such that there isn't a lot of space between individual particles, and therefore those particles are not capable of moving around too much, which basically means that they have lower kinetic energy as well. Liquids, on the other hand, have more space between particles than solids do, which allows the particles greater freedom to move, which therefore leads to the properties that we just discussed. Gases, on the other hand, have huge interparticle spaces. They have large amounts of empty spaces between individual particles, which basically then leads to the fact that those particles can move very, very freely. They have very high amount of kinetic energy. They therefore can fill up the space given to them in a container and take the shape and volume of the container. Because of that space, they are also easily compressed because you can just squish that space out. So the differences in the properties between solids, liquids, and gases that we observe arise from this one basic difference between the three physical states of matter, and that is the interparticle distance. Solids do not have a lot of space between particles. Liquids have slightly more space than solids do, but gases have huge amounts of empty spaces between particles. So, if you were to Google solids, liquids, and gases or on the internet, you'll come across many websites that will provide you with some very interesting animations that may help you understand the three physical states of matter more. So please go ahead and do that. I've just provided a couple of examples of those, but there are lots of others as well. I would encourage you to do that. The physical state of any substance is a function of the temperature and pressure. For example, water can be present either as ice, that's a solid, or liquid water that we drink, or water vapor, that's a gas. Which state water is present in at a particular time depends upon the temperature and pressure at that time. If the temperature is high at a certain pressure, water may be present as a gas, or if the temperature is very low, it may be present as a solid. Or if you change the pressure keeping the temperature constant, then also the state of water may change from one to the other. So which state a substance is present in at a time depends upon the temperature and pressure at that time. Oftentimes, the state of matter of a substance change from one to another. Whenever a substance changes its physical state, we call that either a change of state or phase change. So whenever you hear the term phase change, please remember it implies change of state. Here are some terms that are listed on this slide that you should know as to what these terms mean. Melting is a process where a solid goes to a liquid. Freezing is the opposite of melting, where a liquid turns into a solid. Evaporation, which sometimes people use as boiling as well, although there is a slight difference between the two. But evaporation or boiling is a change where liquid turns into a gas. Opposite of that would be condensation. Sublimation is a process where a solid directly converts into a gas without going through the liquid phase. There are quite a few substances out there that sublime. For example, caffeine is purified by sublimation. Camphor sublimes. Dry ice, if you've ever seen dry ice, goes directly from solid to gas without converting into a liquid. So that's a sublimation process. Opposite of sublimation, where a gas directly converts into a solid without going through a liquid, is called deposition. And then distillation. Distillation is a very common technique used to purify liquids. Distillation is a two-step process where the liquid is first evaporated into a gas, and that gas is collected and condensed back into a liquid. It's a very common process for purifying liquids.